Today, we'll be solving LeetCode 146, LRU Cache. We first create a node class. This is a helper class to store each key and value pair, along with pointers to its previous and next nodes in the linked list. Next, we define our LRU Cache class. In the init method, we take the capacity, store it, create an empty hashmap, and then set up two dummy nodes called left and right. The left node represents the least recently used end, and the right node represents the most recently used end. We connect them so that left's next is right and right's previous is left. These dummy nodes make adding and removing real nodes simpler because we always have neighbors to work with. We also define two helper functions inside the class. The first is remove node, which disconnects a given node from the list by linking its previous node to its next node and its next node back to its previous node. This works in O of one time because we have direct pointers. The second is insert node, which always adds a node right before the right dummy node, meaning it becomes the most recently used. We connect the nodes previous to right's previous, and the nodes next to right, and then update the neighboring nodes to point to this new node. Now, the get method takes a key. If the key exists in our hashmap, we first remove that node from its current position in the linked list, then insert it at the most recently used position by calling our insert helper. Finally, we return the node's value. If the key is not found, we simply return -1. The put method takes a key and value. If the key already exists in the cache, we remove it first from the linked list so we can update its position. Then we create a new node with the key and value, store it in the hashmap, and insert it at the most recently used position. If adding this new node makes the cache size exceed capacity, we remove the least recently used node, which is the one right after the left dummy, and also delete it from the hashmap.